Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at how to solve exponential equations. So we're going to be given here the equation 4 to the x is equal to 15. So the way that I'm going to approach this problem, which is different than the approach your textbook takes, is I'm going to apply the definition of a logarithm here and say that log base 4 of 15 is equal to x. And then, of course, I can use the change of base formula to say ln of 15 over ln of 4 is equal to x. And I end up getting, if I punch that in my calculator, $1.9534 is approximately equal to x. We use that squiggly equal sign to indicate that it's approximately equal, mainly because we don't have enough decimal places to give an exact answer. The only exact answer we could give is log base 4 of 15, or some log 15 divided by the same log of 4. And this is true even if the things are a little bit more complicated. But there is another key way of doing this the textbook does illustrate. If you get a problem like 27 to the x plus 3 is equal to 9 to the x minus 1. So here we don't have a way of taking a log base one of the sides because we're going to end up with something more complicated. But we're going to observe here that 27 is equal to 3 to the third, and that 9 is equal to 3 squared. So I can rewrite this problem as 3 cubed to the x plus 3 is equal to 3 squared to the x minus 1. Now the rules for exponents say if you take a power to a power, you multiply the exponents. So I get 3 to the 3x plus 9 equals 3 to the 2x minus 2. And now there is a very nice property that says if the same base raised to two different exponents is equal, then the exponents have to be equal. So 3x plus 9 equals 2x minus 2. Go ahead and subtract 9 from both sides. And then subtract 2x from both sides, and I get x equals negative 11. Now the other situation that you're going to deal with before we move on to special forms is going to be something of the form 5 to the x minus 2 equals 4 to the 2x plus 3. So this is actually one of those cases that I'm going to go ahead and follow a method similar to what the book does. I'm going to choose a log to take at both sides. I'll go ahead and make it ln. So ln of 5 to the x minus 2 is equal to ln of 4 to the 2x plus 3. And now, following the rules of logarithms, I get x minus 2 times the natural log of 5 is equal to 2x plus 3 times the natural log of 4. I can go ahead and perform the distributive property here. So we get x ln 5 minus 2 ln 5 is equal to 2x ln 4 plus 3 ln 4. So now I need to get the terms with the x's together and the terms without the x's together, so I'll subtract 2x ln 4 from both sides. So I have x ln 5 minus 2 ln 5 minus 2x ln 4 is equal to 3 ln 4. And now I need to add the 2 ln 5 to both sides. So x ln 5 minus 2x ln 4 is equal to 3 ln 4 plus 2 ln 5. We can factor an x out of the left-hand side here. So x times ln 5 minus 2 ln 4 is equal to 3 ln 4 plus 2 ln 5. And then we're going to divide both sides by ln 5 minus 2 ln 4. And we end up getting x equals 3 ln 4 plus 2 ln 5 over ln 5 minus 2 ln 4. And we can go ahead and punch this into the calculator to get an answer, or get an approximate answer for this. So get x is approximately equal to, don't forget my parentheses here, 3 ln 4 plus 2 ln 5 divided by ln 5 minus 2 ln 4. So remember, when you put this into the calculator, the numerator needs to be in parentheses and the denominator needs to be in parentheses. I get an approximate answer of negative 6.3429. So that concludes this video. In the next video, we're going to take a look at what we can do when we don't have stuff added to the exponentials.